Actually fine because if the less people come, there's a little chance for other people to ask me something weird question.
Okay, Feng, hold on.
Yeah.
Welcome everybody to TorCHI. This is our PreCHI 2024 session where we have 4 brilliant students from University of Toronto's Dynamic Graphic Project sharing their talks that were accepted for presentation at a conference which is extremely competitive. Something like 1 out of 10 papers get accepted. So congratulations, you guys, on being accepted. And we're going to hear their talks. They are 12-minute talks followed by Q&A sessions. So on that, we are recording the session. So Feng, you're up. You're on. Go for it.
Okay, sure. So thanks everyone for coming. And slightly sorry because it seems like my paper is the only one don't care about any large language model as the current trending. It's a kind of traditional study paper called the PhoneInVR, which is an evaluation about spatial anchoring and interaction techniques for smartphone usage in VR. This work was done by me and with my lab mates Marshall Sosa, Louis Seidenberg, and supervised by Toby Grossman. The background is very trivial and easy. That is, we trying to learn, which is a weird but actually hidden question, like how people can using the phone in the VR in the best form fact and the input technique combined all together. This is actually under tendency for today. That's just especially for the Apple Vision Pro. I don't know if you have tried it or the similar like Quest 3. There is a tendency to not only using the XR headset like an individual device. Instead, people trying to connect existing electronics like their laptops and the smartwatch and the smartphone all together. And specifically for the smartphone itself, it has a unique stats because it's actually nearby and familiar for everyone, right? So potentially you won't have your wallet in your pocket every day, but you definitely will have your phone with it every day. And meanwhile, it can also provide the haptic and the precise input, relatively precise. That is a lack for the VR system. This is actually a hot topic, and a lot of research works trying to explore what is the potential ability to actually using the phone in the VR. Other than enabling the phone, most of work trying to say what is the benefits, like you using the two devices all together and creating something beyond the familiarity. But for our work, this one is slightly boring because we really want to know like how the best form factor of just you enabling phone as a phone, not a very fancy controller or something beyond phone. Just help people to browse the internet or reply the message and has a big context and which is similar to the what some of the current product and some those are actually commercially conceptual, it's not released yet. How those things could work. And once we trying to looking into the best form factor about how you actually enabling the smartphone use in the VR, we find that it actually has a blurred space. That is actually very unclear of where the virtual phone interface should be anchored. Many people by its nature thinking, okay, maybe we just tracking your mobile phone and it shows the intermediate interface exactly on your physical phone and you're doing the interaction exactly like how you do in the real world. But potentially that thing is reluctant since everything is represented in the VR. Maybe we can just you're doing a gesture and making the interface floating over your hand and you can do the operation. Or maybe it's similar like other application that you actually have a floating window and then you can interact with your content. And also, potentially, the big thing for the phone is it's increasing a space called direct manipulation, which means that you can actually operate the phone exactly where your finger touch on it. But in the VR, another paradigm or the standard of our interaction is basically the spatial input. And it is actually slightly unclear of just what is the best combinations and for the representation and the interaction techniques in the VR, and will those different combinations influence the performance in general, and what are the user preference regarding those combinations? And when we're trying to searching for most of the stuff, we suddenly realized Boo. No one answering it. And then we decided to making a study to figure out all the performance and other stuff all together. Okay, so before we dive into the study, we need to understand what's potential spatial anchorings and the interaction techniques. Just as introduced, we first setting up 3 different spatial anchoring strategies. Phone locks require you actually tracking a phone, track a phone, and then meanwhile just represent it just exactly as how you're using the phone in the VR. And the hand-locked one means you literally have nothing in your hand, but you can actually summon a phone, virtual phone, and you can interact exactly like how feels like you are using a phone, but nothing actually in your hand. So word-locked one is more general and easy to do, but you have a floating on space window you can operate with. For the interaction techniques, we decide not to dive into something super fancy. Instead, we just using the direct manipulation and the pinch for our study. Just either like how you're using the phone in the real world, how you're using the phone exactly just like other application in the VR. And to understand the different performance requirements, we're making the user studies. And the user study, we're setting the tasks like a very common setup, like the target acquisition, swipe, and scroll. For target acquisitions, so we just setting up different distance and the size that represent the common tasks like just the icon and the keyboard stroke size for the mobile phone usage. The swipe is similar like how you're actually doing the gesture, which is also common. We're setting up the 4 common directions and recording all the performance. The scroll one, so exactly like how most of people claim they are wasting time in the social media and like the TikTok, right? That is so common. You swiping, scroll the data. And that is important in the recent days about how the phone being used. So we also measure it. And we prize 24 participants. And with these 3 tasks, all 3 tasks evaluated with 3 different anchorings, multiple to input altogether. Study results are slightly straightforward. So for the target acquisition, so we measure the acquisition time and the arrow distance. And we finding that if we can providing a physical phone is going better, like the phone locked one going the quickest, and the touch with the phone locked even going faster than the pinch. But if there is actually no physical instance existing there, you can do the pinch, which is performance way better than the touch for both time acquisition and arrow distance. For the swipe, we measure the swipe time and the swipe distance, which just how long you will swiping on, and the swipe angle that different with the target. And we finding the swipe distance and swipe angles have some statistic difference, but the arrow are too tiny and nothing important to report. But for the swipe time, which is working exactly similar like the tendency about how you're making the target acquisition, that the phone locked one going faster, especially with the touch. And if the physical in the surface is not provided, you can do the pinch going way faster. For a scroll, we measure the scroll time. Basically, like just there is an aim number, and you're trying to finding the line and to evaluate the time, and measure the ended arrow distance. Like just once you stop, where how far it is away from your target, and the scroll travel distance, which also shows a similar result from target acquisition. That if you can providing a physical instance, the phone locked one with touch going the shortest scroll time and the pinch going faster than the most of if the haptic is not provided. And the touch with the physical also providing the better accuracy in general. But meanwhile, the pinch also leading to the shortest travel distance in the spatial environment, which is also something important. And for more details, please refer to the paper. For the user preference, it is obvious and straightforward. There's a phone locked one just being ranked as the most welcomed one. And but if we do not have the physical instance, the pinch overwhelming being welcomed for the word locked and hand locked condition. So that is the general stuff. It's basically a study just trying to figuring out the combination about the spatial anchoring and input techniques. There are lots of limitations. One limitation is that we assuming the interface will be mirrored into the VR, but the decent video see-through techniques going so good. The one I showing here is something at the moment we're doing the study, even the best one cannot just enable a reasonable phone usage. But with today's Apple Vision Pro and the Meta Quest 3, the video see-through quality is so good. Potentially people can trying to say if those video see-through has a different performance in general. And also something similar, different, like the alternative form factor and the different scales. For example, like the second page shows, we can have a huge arbitrary size window in the VR, right, to represent your phone. Maybe the performance will be different. And we only doing the abstract study. We don't care about the real world applications and also with augmented content. Maybe those things could also leading to different results and it can be developed further. Okay, thank you so much. Feel free to ask me any question if necessary. Thank you so much.
Hey, great job. Thank you,
Thank you.
And you have 2 minutes to spare because it's supposed to be 12 minutes, right?
So I do 10 minutes, I do 12 already.
Okay. All right.
How long I did? Sorry about that.
I think mine was about 10, I counted.
Oh, that's good. Yeah,
I was
so our session required to using 10 minutes.
okay.
I think
So
the
then
yeah,
you're right on.
yeah,
Okay.
that's good. Yeah.
We have 11 people in the session. Yay. Thank you everybody for joining. Sorry for the delay. And if anybody has any questions for Feng, that was a very cool VR. What were some of the biggest challenges of running the study for you?
So okay, so if we're trying to making a study in the desktop, right? So we have a mouse, we click the something and something react, right? We don't need to reinvent the touch event itself. But to be honest, in the VR, even with a decent SDK and stuff, whether you touch on a phone and where you're touching is, and whether those track the components are there, and even like just you have application and you're trying to or interact with that, those are not straightforward. You basically need to reinventing a low level Android system in the VR and then making it.
Wow.
Yeah, that's a huge part. That's also I think part of the reason why such a looks like easy study didn't exist at all.
right.
Yep.
So you're doing virtual phone in a virtual space with virtual interactions, and how much training is going to be a big barrier for all the users, right?
The users don't feel the barrier. I mean, most of people, unless the reborn infant, right? Even the children know how to use the mobile phone today.
Okay. Yes.
Yeah,
Yes.
so
But
that
in the
they don't
VR,
need.
yes, the VR
Yeah,
challenge.
no. Once they okay, so that's another interesting finding. So if you putting the user directly into the VR and first time showing them, okay, you can use in pinch to operate something a fancy, dancing guy in the VR, you can interact with him. People will feel afraid. But once they look at something similar like a mobile phone, they will put their hands in trying to do this.
All right. So
Very intuitive finding, actually.
nice.
Yeah, that's also potentially, I think the next paper we were talking about the procrastinating. I'm brilliant at procrastinating for people in the VR.
Right. Well, thank you so much for your presentation. It was very interesting work. All right, and good
Thank you
luck
so
at
much.
the conference. Okay, who's gonna go next? Oh, wait, hold on. Make sure nobody else has a question. Anybody in the audience? Feel free. If not, we will continue to the next presenter. Okay, looks like no
Right,
need.
I could go next unless Majeed or Ananya wants to.
Go ahead.
All right, let me share my screen. Okay, share.
How many minutes are you?
10 minutes.
Okay.
All right. Okay. Hi folks, I am Mohi Reza. I'm gonna be talking about a novel human AI co-writing system called ABScribe, which improves how we can explore and organize multiple writing variations when we're trying to revise text using large language models. If you're impatient like I am and want to look at the paper in the slides now rather than wait for later, you could scan these QR codes. And don't worry, you don't have to rush to take out your phones. I'll leave both of these codes at the corners of my slides. So at any point during the talk, if you want to access the paper or the slides, you can do so. All right, so I want you to take a moment and think about generative AI tools for text manipulation and your experience with them. What would you say is common in terms of how we interact with these state-of-the-art large language models these days? So think about how you use ChatGPT or Google Gemini or Meta AI or any of these interfaces that have been gaining increasingly popular. So what's common across these interfaces is that these are all chat-based interfaces. So chatbots are the predominant UI for these tools these days, right? So in this talk, I'm going to argue that if you're trying to revise text, these chat-based interfaces, while they're super easy to use, aren't necessarily well suited for text revision, especially when you're trying to explore and organize multiple writing variations. So let's look at an example to understand what I mean. So let's say you're trying to write an email and you open ChatGPT, right? Let's say I want to write an email to request coffee chats with folks attending CHI, right? So I can tell GPT exactly what I want, who I am, and the kind of email that I hope to write, okay? And then once I write this prompt and I press enter, GPT quickly whips up this draft, right? And this kind of text is really useful as a starting point, right? And these large language models are remarkably good at generating text like this. But of course, the text that we get isn't perfect, right? It's rarely exactly what you want. So we also want to be able to revise the text that's generated from the AI. And when we try to engage with text revision tasks with these LLMs, using this chat interface, we'll run into some issues. So for example, let's try to create some variations of different parts of this email. Let's say we want to make the subject line shorter, right? So one of the first issues I'll highlight is that as you generate more and more variations, it's hard to trace these variations back to the original draft. So let's say I want to make the subject line shorter. So I ask the LLM to do that, and then I press enter, and it gives me a shorter subject line, but the subject line is now disconnected from my original email, right? And if it's only a few variations, that's okay. But let's say I wanted to explore other things. So let's say I want to make the second paragraph slightly less formal, right? I press enter, GPT gives me a draft. Let's say I want to do more, right? Let's say I want to enhance the tone of the second last paragraph to show more excitement. I press enter, GPT gives me a draft. Now I end up with all of these variations of different parts of the text, and I can't quite see how it fits into my email, right? So there's this difficulty of tracing multiple writing variations back to the original draft. Another issue that these chat-based interfaces have is it's hard to reuse the prompts that I've already written without rewriting the instructions again and again, right? For example, let's say the piece of text that I have generated, let's say I want to make it shorter and less formal. I've previously made other parts of the text shorter and less formal, but for me to apply those same instructions to this chunk of text, I have to rewrite the instruction. So I rewrite it, press enter, and then GPT gives me the output, right? And this can get tedious as you're working with a large number of variations. Finally, when you have all of these writing variations and you're ready to put together a draft, it's difficult to compare them to figure out which one to use because you have to switch back and forth between this chat interface and your text editor. So let's say I try to do that. So I copy the email into a Google Doc, I paste it, and then I have to go hunting by scrolling through my interface to grab the pieces that I want as I cherry pick the parts that I like and form the email, right? So the question then becomes, how might we enhance this text revision process, using AI to better support writers in handling multiple text variations? So that's where the interface elements in ABScribe can help. So let's see a quick demo of how it might work. So here's ABScribe. It looks a lot like a word processor that you might already be familiar with. But in ABScribe, you could stream text from the large language model directly into your document. So I just copy pasted the same exact prompt I used in the previous demo, and then I press enter. Now the text from GPT-4 is directly streamed into the document, and then I could accept it and then directly modify it in place to suit my needs, right? What I can also do is I could select specific portions of the draft for which I want to explore variations. For example, I selected the subject line, and then I can ask the AI to modify it in some way, right? Let's say I want to make it shorter, and then I click a button, and then it gives me another variation. Now I can compare the two by hovering over the pop-up toolbar right above, right? So I could see the modified text in context of the rest of the email. I can also clone a particular variation and then edit it to change it however I want, right? So it's like I could take a text from the AI, modify it using the AI, and then edit it to my liking. And then let's do it for another part, right? Let's say we want to work with this paragraph, and we want to make it slightly less formal, right? So I click on the button and I get a variation generated. And then I could compare the two, right, by hovering over the buttons. And then, of course, the variations generated by the AI might not always be what I want. So I can then tweak around with the prompts that I wrote, right? Let's say this is way too informal. So I want to say that, make it less formal while keeping it professional. So I hit save, and then let's say I'm done editing. And now to see how the changes to my prompt reflect the draft, I click on this button, and then I get a new draft. So all of these variations are stored side by side for me to compare and contrast and edit, right? Let's say I like that one, I select it, and then we could do something similar with another piece of the email. Let's say I want to enhance the tone. Notice that whenever you write a prompt in ABScribe, it converts it into a reusable button, right? So we have a shorten button, an informal slightly button, and an excitement enhancement button. And so the next time I want to do something that I've already done previously, all I need to do is click on the button for it. I don't have to rewrite the prompt. Let's say I want to informalize the speech slightly, and let's say I want to shorten it. So I click on that button, and it generates the variation for me. And I can compare all of these side by side. What I can also do is I could use the sidebar, the variation sidebar, to systematically go through the variations that I've generated and then pick the ones I like, right? So using this kind of interface, we make the text revision process using large language models a lot easier. Okay, so to evaluate these interface ideas, we conducted an evaluation study with 12 writers where we compared ABScribe with a baseline interface involving a chat-based UI like ChatGPT, right? And then we asked users to rate their workload using NASA TLX. And we also had them rate various aspects of the revision process to kind of gauge their user perceptions. And we interviewed them to understand their experience. And what we find is that ABScribe significantly reduces the subjective task workload of the revision process while simultaneously enhancing user perceptions of the revision process. And if we dive deeper into the revision process, we see that across the board, ABScribe reduces document clutter. It helps users explore a greater number of variations of increasing granularity, right? It helps them search through the variations using the sidebar. It helps them compare and edit variations. So you could see that with ABScribe, the blue indicates higher ratings for that particular item compared to baseline, right? In the paper, I delve deeper into the user interviews and other elements of the study. So I encourage you to check it out. Here's the link to the paper, and I'll be happy to answer any questions that you might have. Thank you.
Hey, that's a beautiful job. Wow, what an amazing system. I want one. I think everybody in the chat is agreeing with you. Everybody wants one. And I love your dynamic buttons. My God, if you could just do that everywhere, wouldn't that be amazing? Of course, we want to just ditto. Wow, beautiful work. And you went a little bit over time. I didn't want to tell you, but I think about a minute over. So you might want to just a little tiny bit. I don't know how strict they are in the time presentation. Does anybody else have a reaction or comment or question? That was amazing. And you built all that. When can we buy it?
I open sourced it, so you could just download it and use it for free. Yeah.
Beautiful. And how long did it take?
Several months. Yeah.
When are you finishing your PhD?
Oh, that's a good question. I hope soon.
Okay.
Yeah, I'm in my 4th year. So
okay. Well, I think that was brilliant. One tiny comment when you're doing the final results presentation, the 2 tables, if you see the color differential at the start, it would be much easier to try to track. Yeah. As opposed to like I'm trying to make heads and tails of it, and then you're going back and forth. So maybe polish up that last bit for the presentation, right?
Yeah.
So like people are not going to do everything, but if you point to like a couple of points on it, that might be easier to handle.
Yeah, that's agreed.
All right. Any other questions, comments, other than amazing reactions and loves and thumbs up that you got in the chat? You can go see those. All right. Thank you very much. Thank you for sharing.
Let me figure out how to stop sharing the screen.
Hey.
Okay. Yeah.
Great. We have our next presenter.
Majeed can go or I can go. I'm fine with both.
All right. Well, I can go next then.
Right.
Second. All right. Well, hi, everyone. Thanks for joining this presentation. My name is Majeed. I'm a PhD student at the University of Toronto, and today we'll be presenting our paper about CodeAid, an LLM-based programming assistant for educational settings that balances student and educator needs. And just as a side note, I think this should be a 12 to 13 minute presentation. So I'm not that worried about the timing. Okay. Anyways, all right. So as more students are becoming interested in learning how to code, programming class sizes are expanding. This makes it increasingly challenging to provide immediate assistance to students when they need help. Traditionally, office hours are often poorly utilized and are not equitable. Therefore, we need alternative solutions that are scalable, equitable, and student-friendly. Currently, AI tools based on large language models like ChatGPT can help students by explaining, generating, and even fixing students' code at any time of the day for any student. but LLMs generate direct solutions, which might prevent critical learning, and their pervasiveness is concerning, particularly on academic integrity and students' over-reliance on AI. Therefore, we developed CodeAid as a Q&A programming assistant that balances generating helpful and correct solutions while not directly revealing code. CodeAid was built with 5 main features. General question to ask high-level programming questions, such as inquiries about a specific function or a concept. Question from code to ask specific questions from a given code. Explain code to provide detailed explanations. Help fix code for debugging and identifying issues. And help write code to assist students in writing code. To ask a question using CodeAid, students simply need to type their question and provide relevant context, such as code. And CodeAid will immediately start streaming a response that includes multiple interactive components. First, they can read the AI's natural language explanation. They can go through a generated pseudocode and understand how it works by hovering over each line. And they can see documentations for functions relevant to the input query. The general question from code, and help write code generate responses that include a natural language answer to the student's question, the pseudocode of the specification they requested, or an example code relevant to their question, function documentations relevant to their question that are retrieved by the AI and are not AI generated, and the ability to ask follow-up questions to further clarify the AI's response. The help fix code responds back a natural language description of fixes that students need to do and highlights specific lines in their buggy code with suggested corrections, without directly showing them the fixed version of their code. The explain code feature produces an interface for the student to hover over each line to see an explanation about what each line is doing and why is it needed in the code. A summary of the entire behavior is also provided. In terms of implementation, CodeAid was developed using OpenAI's models, particularly GPT-3.5. It streamed the generation and rendering of interactive components to allow students to see responses immediately, just like ChatGPT, which streams the responses. It used retrieval augmented generation to display function documentations relevant to students' queries. So the function documentations are not AI generated. They've been validated by the course instructors. And we also use chained LLM prompts together for various features. And for example, in the help fix code feature, the system first generates the fixed version of the student's buggy code and then generates a list of natural language fixes based on the fixed code. However, we do not display the fixed code to the student. Please read our paper for more details about CodeAid's implementation. We deployed CodeAid as an optional and additional resource in a class of 700 students for their entire 12-week semester. Using ChatGPT was not allowed in this class, and it was a C programming class, a second-year level class. We tackled 4 main research questions in our deployment. First, what were students' usage patterns? How are students using CodeAid in terms of frequency, choice of features, and the nature of inquiries? Second, how was CodeAid's response quality in terms of correctness, helpfulness, and not directly revealing code solutions? Third, what were students' perspectives about CodeAid, its perceived utility, and comparative advantage over existing resources, including ChatGPT? And lastly, what were the perspectives of educators about CodeAid? I mean, other educators, in terms of effective pedagogy and curriculum integration. We collected data from 5 main sources. First, weekly surveys that asked about students' usage of various educational resources, why they used or not used CodeAid, and what they liked or disliked about it. CodeAid's embedded feedback mechanism for each response that asked students to rate the response after it generated a response, semi-structured interviews with 22 students, final survey about their usage of CodeAid compared to ChatGPT, and 8 interviews with computing educators. In terms of results, we first look into questions asked from CodeAid and our thematic analysis on them. Throughout the semester, about 370 students used CodeAid frequently, and asked about 8,000 questions. Around 160 students used it less than 10 times, while 62 students used it more than 30 times. Women used Code8 significantly more than men, while representing only 30% of the entire class. The most frequently used feature was a general question, followed by ask question from code and help fix code, whereas the explain and help write code features were used considerably less. A thematic analysis of nearly 2,000 questions from Code8 showed that students used Code8 mainly for asking programming-related questions, debugging code, writing code, and explaining code. I'm going to explain these in detail right now. When students used Code8 to ask programming questions, students mostly used it to ask it for conceptual questions about syntax, pointers, string operations, and so on, followed by asking about the behavior of arguments, return types, and of specific functions. However, somehow unexpectedly, sometimes students use Code8 similar to a compiler to verify execution or evaluate their code on particular inputs. For debugging, students predominantly use Code8 to help them fix their buggy codes. However, they also use it in less direct ways, to identify the source of their errors and to interpret encountered error messages. When using Code8 to help write code, in about half of the cases, students asked how-to questions about a specific task. However, in the other half, they were asking Code8 to generate the direct code solution, such as by copying the entire task description of their assignments. On explaining code, students mainly used Code8 to explain code, such as the starter codes provided in their assignments. Now, in terms of the quality of Code8's responses, we looked at its log data and our thematic analysis of the responses. Overall, about 80% of the analyzed responses were correct. However, the correctness of features varied significantly, with the general question, explain, and help write code features all responding correctly in 90% of the times. However, the help fix code and question from code being correct only in 60% of the times. In terms of not revealing direct solutions, as instructed, Code8 almost never revealed direct code solutions. Instead, it produced natural language responses, pseudocode, and suggested fixes. Now, we turn into the student interviews and surveys to understand their perspectives about Code8 and its comparative advantages. A recurring theme was how students appreciated Code8's 24/7 availability and being a private space to ask questions without being judged. Students also appreciated Code8's contextual assistance, which provided a faster way to access relevant knowledge, be able to phrase questions however they liked, and producing responses that were relevant to their course. When asked about learning, students reported that responses were deep and clear. However, some students indicated that they wanted less direct responses, like hints, particularly when using Code8 to debug code. Interestingly, some students regulated themselves to not use features that produced more direct responses. In terms of trust, comments were mixed. Some students trusted Code8 and others found that it couldn't lie to you and some students trusted Code8 and others found that it can lie to you and still sound confident. We also found that being part of the course and the instructor's endorsement also increased trust. One student said that they trusted Code8 even more than Google just because it was part of the course. When we asked students why they did not use Code8, the primary reason was a perceived lack of need, followed by their preference to use existing tools, such as debuggers, and wanting to solve problems by themselves, or just had a general lack of trust over AI. In the final anonymous survey, we asked students to compare Code8 with ChatGPT. Although ChatGPT was prohibited, students used it slightly more than Code8. They preferred its easier interface and larger context window to ask about larger code snippets. However, some students did not like that ChatGPT did a lot of the work for them. Now, to understand how other educators would use Code8 and integrate it into their curriculum, we interviewed 8 computing educators. Overall, most educators like the integration of pseudocode with the line-by-line explanations, as it provides structure and reduces cognitive load, and is better than finding exact code solutions on the web. However, some educators were concerned that when the algorithm is what the students need to learn, revealing its pseudocode will be harmful to their learning. Additionally, since most educators found access to ChatGPT to be harmful for introductory level programming courses, they wanted to keep students away from it. For that, they would rather encourage students to use Code8 and suggested integrating an editor with code execution so students would work on their tasks right inside Code8. Educators also wanted the ability to customize Code8, such as when to display pseudocode and when to not display pseudocode, and update its content with course topics. Lastly, most educators wanted a monitoring dashboard to see a summary of asked questions and generated responses and to reflect on their own instruction. However, very interestingly, educators also mentioned that students should not feel like they are being watched. Now, let's look beyond Code8. Our results and experience developing Code8 enable us to propose design considerations for future AI coding assistants in educational settings. We identified 4 major design considerations, each positioned with a student's help-seeking process with an AI assistant. The first question is, why should a student use an AI tool compared to other and traditional non-AI tools available? So, how does a learner know when to use an AI assistant? This requires clearly exploiting the unique advantages of AI over non-AI tools. Once a student has decided to use an AI assistant, how should they ask the questions from this AI tool? Or should the AI tool itself recognize the problems and proactively help the student? How should the input be designed to balance user-friendliness and metacognitive engagement? Third, how direct should the AI respond? How should it balance between students' productivity and learning engagement? And finally, how to support students in validating and verifying the AI's responses. With that, I would like to conclude this presentation. Please read our paper for more details about Code8, its iterative development, and how our results point to specific directions in the design of future pedagogical AI assistants. I would like to thank all of my collaborators, especially Professor Michelle Craig, who initiated this project, and my PhD supervisor, Professor Toby Gresham. Thank you very much.
Bravo. About 15 minutes worth of talk. Okay, great job. Very impressive, 700 students in the analysis. Great design of the study. And of course, the tool itself. Wow. It's different times for learning coding. Amazing. Does anybody have questions for Majeed?
I had a question, Majeed. So I
Yep.
think you mentioned one point about hallucinations, right? Sometimes the LLM would lie to the student and be confident as they say it. I'm curious, did you have instances where students actually spotted an error from the LLM? And would you say that there are any learning benefits that might come out of spotting an error from the LLM and fixing it?
Yeah, that's a great point. We did find a lot of instances in which students, so basically after each response, the students had to rate that response.
Mm-hmm.
So and they could write something like a very small feedback. And we found a lot of cases, particularly with the help fix code feature, that students basically said, "Oh, this is completely wrong," and they understood that.
Mm-hmm.
However, we don't know if they immediately noticed that, or they, for example, they implemented what was suggested by the AI in their code and then understood that this was wrong. But yeah, that's definitely something that we did not look into, if there was a learning gain in that. It's very difficult to measure such learning gains, but it would be very interesting to look into. Overall, I would say like these types of self-regulated behaviors in which students just do not over rely on the AI and whatever it's telling them is definitely showing that these students are cognitively engaged in the task that they're working, and they're just not simply over relying on the AI, which is great. And something that is being discussed a lot is that in the age of AI, these metacognitive skills such as self-regulation, feedback, and those types of things are the important things that we need to teach to students. So yeah, it was really interesting to see some of that.
Great. If there are any more questions? Okay.
All right.
Let's go to the last presentation. Well done. Everybody so far, very punctual, very smooth, great delivery. All around, congrats. Great job.
All right. Can everyone see my screen?
Yes.
All right. So yeah, my name is Ananya Bhattacharjee. I'm a PhD candidate in computer science at the University of Toronto, and today I'm going to talk about how AI and LLMs can help with academic procrastination. So this talk is based on our PreCHI.2004 paper, which got an honorable mention. In this work, we explore the role of large language models in personalizing and scaffolding strategies to combat academic procrastination. We have had a long list of authors, most of us from University of Toronto, but we also had collaborators from Northwestern University and Microsoft Research. So before I start, I'm gonna give like 5-10 seconds to scan if you want access to the preprint. And yeah, while I do that, I was gonna supposed to like introduce some of my collaborators here, but they probably didn't join. All right. So yeah, procrastination is something that I think many people in this room even relate with. It's defined as the intentional delay of tasks, despite known negative consequences, extremely widespread in academic settings. And prior research has found that at least half of all college students engage in chronic procrastination. Now, researchers over the years have developed a range of interventions for procrastination management. Many of them focus on time management or task completion or providing personalized motivation. But a recurring critique is that they often fail to acknowledge the individualized factors or complex factors that contribute to procrastination. We often view students as only students, but they're human beings too. So they have their own social environment, family duties, and personal goals, which play very important roles in procrastination. But they are very difficult to integrate into the design, very difficult to design around these issues. So in this work, we are curious to see whether large language models with their sophistication and computational prowess can enhance existing strategies. They have a lot of potential capacities, like users can engage in open-ended conversations. Already, LLMs have been used in so many settings for generating personalized advice and suggestions. LLMs can act as supportive scaffolds, as we have seen already in this session. But there are a lot of challenges. LLMs currently lack subjectivity. They can't innately understand human situation. You need to provide input. There is lack of knowledge about which intervention elements users may wish to personalize, and there are lots of ethical considerations and guardrails. So being motivated by these opportunities and challenges, we formed 2 research questions. In the first one, we wanted to see how users envision the role of LLMs in tailoring strategies. And secondly, we wanted to see what challenges or tensions might arise when we use LLMs for such setting. So we did a multi-phase study to investigate these questions. So we first designed a functional technology probe. So our goal was not to propose and validate its design, rather we designed it to gather informed feedback from users. So we designed Spark, self-generated personalized articulations and reflections kit, which is a web-based tool that utilizes GPT-4 to offer context-specific advice. And the tool was iteratively developed by our multidisciplinary team members. So when users engage with Spark, they first see a seed message, which is grounded in existing theories on procrastination management. It provides you some tips on how you can manage your situation, and it's supposed to act as a generic blueprint. But then we provide interface options to generate context-specific messages. So to do that, what we do is we first let users explain their situation in as much detail as they want. Like, as you can see, like someone was talking about their final exams and all of their other responsibilities. We provide them multiple options like their preferred tone, their preferred level of directedness, or the instruction level they want. And based on their preferences and situation, then you can see that the GPT generates a message personalized to them. Then we let them do some back and forth, like they can make personal requests to like make this message sound more encouraging, or they can edit the response themselves to suit their purpose. We also provide interfaces for prompting future action to foster proactive behavior and to transform intentions into actions. So what we do is we let users draft an email about their future self, like what they would want to do, how they are visualizing the future, and they could then email that message to their future self. And like before, they could also do some back and forth with the email they have written. Now, in the next stage, we did engage users for 15 university students who engaged in an interview or focus group discussion session, and they provided their recommendations for LLM tool features to address procrastination. Then we took those feedback to 6 experts on clinical psychology and education who offered their perspectives on the user needs, and also they identified some potential design tensions. So we did thematic analysis of transcripts and notes from these interviews and focus groups, and 5 themes emerged that I'm going to talk about. So firstly, participants are looking for step-by-step structured solutions. Almost they compared it to a cooking recipe. And they felt that like breaking down complex tasks into more like step-by-step solutions would make them appear more manageable. But the experts are very concerned about over-reliance on LLMs. They're stressed that spoon feeding is not an ideal solution. So there should be some rooms for independent exploration. Then there was a lot of tension regarding guided versus unguided questions. Some people were looking for more open-ended questions so that they can explain their situation better. Like, what is something you're putting off for today? How has that made you feel? What made you feel this way? But this sequence of questions can themselves be a source of procrastination because they can require time and effort. So users sometimes may be allowed to choose their preferred level of guidance so that the guidance does not come across as overwhelming. This is very interesting, and I would request you to read the paper to know more about it. Like, there are concerns and boundaries in providing emotional support. Users often said that while expressing their problems, they often might express their emotions or their mental health challenges, and they would prefer some support regarding that. But experts who advised cautions, they suggested that LLM should not take on roles akin to therapists for providing support. Even sometimes the messages generated by LLMs could be perceived as appealing, but they may lack clinical validity. What they said is acknowledgement of emotions should be fine. Like, I understand you are feeling sad, but they should not go beyond that. So there should be clear disclaimers about what these sort of tools can and can't do. Regarding other themes, participants are looking for deadline-driven interactions. They strongly suggested that LLMs could be connected with Google Calendar, Microsoft Teams, or Slack, and they appreciated that we let them schedule emails for future. And some people are looking for collaborative support. They wanted to know what other people are inputting, how they have used this tool, and they wanted to see examples of successful interaction. So if we go back to the original research questions, how do users envision the role of LLMs? There are demands for structured guidance with adaptability. And participants are also looking for ways to integrate these sort of tools with their deadlines and routines. And there are some demands for collaborative support as well. Regarding challenges or potential design tensions, the main one was obviously the boundaries in addressing emotions. LLM should clearly communicate what they can or cannot do. There are some design tensions regarding the optimal level of guidance as well. And experts are also suggesting that there should be rooms for independent exploration, and these sort of tools should not always spoon-feed solutions. So in conclusion, if I summarize, LLMs have the potential to address these diverse individual and social factors in academic procrastination. To explore these issues, we conducted interviews and focus groups with students and experts using a technology probe. We identified a need for structured, deadline-oriented LLM tool guidance, adaptable to user schedules. But we also recommend cautious use of LLMs for emotion management. Broadly, our work highlights the nuanced ways in which users can engage with LLM-based tools. It showcases human-AI collaboration in tackling procrastination challenges and contributes to the discussion on ethical deployment of AI. So that was all. Thanks a lot for your attention. We thank our funders. I'm graduating soonish, so if you want to know more about me, scan this QR code and also reach out to me over email. Thanks.
Great job. Thank you, Ananya. Does anybody have any questions for our final presenter? Overall, guys, great job. Everybody. Very proud to be DGP. And you will do a fabulous job in Hawaii. Yep. Great talks. No more questions? Well, I will be posting the recording on the YouTube channel. You can share those. I think you guys all kept within your time slots and they were very professionally delivered, calm, and presented in a very well-delivered manner. So congratulations all around. Very few changes required. You can go confidently and present at the conference. Great. I'm so glad we made it. Thank you so much for putting up with the slight delay and sorry for the inconvenience. We are really happy we could pull it off and get some audience participation as well. We were 13 people at the top, so good job. And thank you so much and safe travels to Kai and regards to everybody at Kai. Have a good time and dinner's on me when you get back. Ping me, we will organize all that. Okay, I want to hear all about your Kai experiences when you're back. Thank you, guys.
Thank you, Anu, for organizing this. Thanks, folks.
Thank
Bye.
you, everyone. Enjoy your trip.
Yes.
Thank you.
Yep.
Topic